So, hello everybody, my name is Mikko Kivelä. I'm a resident developer here at Smartly, and today I want to tell you a bit about how we have started embracing micro frontends as a part of our frontend development. In order to motivate the why we have actually started adopting these micro frontend workflows, I first want to share a bit about how our frontend actually has been building over the years. So the Smartly frontend started at the same time as the Smartly as a company and all of the other functions related to that in 2014. At that time, the front-end application was mainly developed by 3 developers, and it was part of our single monorepository, along with our backend. The front-end at that time was started as an Angular V1 project. If we then forward a couple of years ahead, our team had already grown in size somewhat, with 16 developers-ish, and that was a bit after I had joined the company, actually. At that time, we had already started adopting a lot of new technologies also in our front-end side. Most importantly, we added React and Redux into the mix alongside Angular V1, and of course a lot of other libraries that supported that workflow. At this point, our engineering team was still one single core team, and the development happened in a single repository still. Now, if we jump ahead a couple of years again, we experienced some significant changes in how our engineering side was structured. So we grew in size to 40 plus developers. At the same time, our core engineering team had been split into multiple development teams, with each of the teams handling different responsibilities and different business domains and so forward. We had done a reasonably good job in the backend side in separating all of our different business domains and requirements into separate microservices. However, on the front-end side, the situation was not quite as sunny. So our front-end was still one monolithic entity, and it was being worked by all of our 8+ development teams. Since we were adding new domains and new functionalities and views to the front-end on a daily and weekly basis, it started to blow up quite quickly, and we encountered a few issues along the way. So because our teams were working on the one single front-end repository, and we were introducing new functionality at such a fast rate, also our build pipeline started to get quite busted. So we were looking at that moment at maybe 1 minute initial build times using our Webpack builds, and also 15-second incremental build times during development. Also, the runtimes for our front-end test suite was getting quite out of hand, with maybe 10 minutes taking to run the whole test suite. And at that point, we couldn't really talk about any hot reloads or fast test-driven development anymore. On the organizational side, we also ran into a couple of issues, mainly code conflicts, since again, all of our development teams were working on the single code base on the front-end side, as well as reduced team autonomy. And by this reduced team autonomy, I mean that every time our development teams needed to make a decision to include some new functionality, some new libraries, or some new tools into their front-end workflow, they needed to also evaluate what that meant from the company-wide front-end build pipeline, what that meant from the perspective of other teams, and how their workflows would be affected by this. And it was clearly not an ideal situation regarding the full development workflow. Now, as applications, specifically front-end applications, tend to grow in size, the build times do tend to get slower in pretty much all of the projects, as we have witnessed based on the Medium blog posts regarding Webpack optimization as well as all the issues in the Webpack GitHub repository. So we were not alone with the issue. And even though we had included all of the different optimization methods, including Happy Pack and all the DLLs and caching and whatnot, we just couldn't at some point anymore get more out of the build pipeline. The size of the application was becoming the bottleneck. So we knew we needed to do something in order to make the situation better. So enter micro frontends. Just to set the base terminology, micro frontends is a term that started popping up around 2016, and on a concept level it meant separating your front-end application into individual entities that handled some specific business domain, functionality, or perhaps part of a bigger process. And then these micro frontends could be integrated back into a single app. The term itself might not be completely novel, or at least approaches related to that, but the tooling, especially the public tooling related to micro frontends, has developed within the few last years quite rapidly. And at Smartly.io, we also felt like this tooling was now at a point where we might be able to jump aboard the train. Now, if we quickly took a look at how the Smartly.io frontend was structured at that point, we had quite a classic web app UI structure with our global navigation and then the individual views. Each of the individual views in our app handled a specific business domain or requirement or provided a specific contained set of functionality. Analyzing that a bit further, we also noticed that pretty much all of our development teams were owning these specific views themselves without much overlap happening between the teams in sense of development. In addition to the development teams owning the specific views, we also noted that all of the core views of our application also mainly interacted with one specific backend microservice that provided the functionality needed for that view. So if we reference that back to the sort of idea of micro frontends, we could clearly see that there were some similarities. So consciously or subconsciously, we had already started working in a way that was quite micro frontend specific. Now the question was just on how we were actually going to split these different parts into their own entities. So when we started our micro frontend process, we set a few goals for ourselves. First of all, we wanted to provide the isolated development environments for our development teams for developing their micro frontends. This meant that the teams should be able to make the decisions regarding the micro frontends and tech stacks they use and the libraries they use and everything that goes along with that. We also wanted to provide lazy loading and code splitting into our main application so that we could load those micro frontends on demand when the users access those. This was also crucial in the sense that we did not want to bloat the existing core application anymore. We also wanted to provide seamless navigation between the different micro frontends, as well as app-to-app communication. In our context, the requirement for the app-to-app communication was mainly that we needed to push some sort of notifications to the parent app and display those to the users without having to implement those notifications patterns inside each micro frontend specifically. As a last point, we also wanted to provide a visual consistency between our micro frontends. So even though our full application consisted of these individual smaller entities, it needed to feel for the user specifically as a one single consistent app. And then looking into how we have actually implemented some of these patterns and how we are working on these in our daily work. So I have set up an example repository here. If a team was working with just a simple single micro frontend, then setting up a basic React app using, for example, Create React App might suffice, and then just distributing that application as a single package. However, in our case, we identified that a lot of the teams were actually working with multiple micro frontends, which required also some additional setup from the structuring of our micro frontend repositories in order to make the development workflow a bit smoother. So we decided to adopt a mono repository approach for our micro frontends. If you have worked with Babel or any bigger JS projects, you're probably somewhat familiar with the structure. So we have our packages folder, which includes a different 4 different folders, and each of these folders represents its own package. Even though these packages all exist within the single sort of Git repository, they are distributed as separate packages. The packages include our 2 micro frontends, app A and B, a child history library asset, and then a shared component A that is being used inside the application A and application B packages. In addition to those packages, we also provide Workbench application in the repository root that is being used for development purposes, and we'll take a closer look at that in a moment. Now, as our tool of choice for managing this sort of monorepository structure, we are using a tool called Lerna. If you're not familiar with Lerna, it is pretty much like a proxy for Yarn or NPM or any of the package managers that you might be using. What Lerna provides on top of the basic package managers is that instead of managing a single package and the dependencies there, you're actually managing multiple packages at the same time. So again, going to our monorepo structure here, we have the 2 different applications and the shared component. Now, if I wanted to add the shared component dependency to my micro frontend applications here, I could simply run, let me just get a bit bigger stat visible. So instead of running yarn add, I could simply run Lerna add and then the package name. So what this does is adds the dependency to all of the included packages in our monorepository structure, as we can see from the package JSONs in the individual packages. In addition, what the Lerna add does is automatically links the local packages between each other. This means that even though our component A has not been published in any NPM repository currently, we are still able to use that as we would any normal NPM dependency or NPM package in our views. So for example, within our application A, we are simply importing component A and using it as a normal package, even though it is a local package. Then if we take a look at our Workbench setup regarding the different micro frontends existing in this monorepository, and we can run the yarn start our Workbench. So what our Workbench actually provides is this simple navigation wrapper for our different micro frontends that coexist. It also provides us an environment to develop these different micro frontends in unison and also all of their shared dependencies. So for example, here I have the different micro frontends and then this sort of view below is being mounted automatically or lazy loaded and then mounted. We have the two microfrontends here, each with two sub-views. Now, if we think about the different types of packages we have in this application and the differences between a component package and an actual micro front-end package, they are both composed of different React components and they are distributed as React components. So what's the actual difference? Well, in our case, the difference between a micro frontend and a component is the routing included in those components. So each of our micro frontend packages actually includes its own internal routing. For example, with the app A, we have the A and B views, and we can see, if you squint your eyes real closely, we can see that the routes are being updated accordingly to the sub-application routing. All of the sub-applications also use this sort of path prefix provided by the parent application. And as we can see from the DOM here, that prefix is also automatically being appended to all of the links rendered in our child application. If we take a look at the actual code of the child application, we do see that we are not specifying the path prefix anywhere in the code. So all of the links existing in our views are actually coded relatively to just a plain route. In order to make this automatic prefixing happen, since we are using React Router, we need to do some history magic. So for that purposes, let's take a look at how we are actually initializing the application history and passing that forward to our child applications. So within our Workbench application, we are using the create browser history from the history package in order to initialize a shared history. Then that history is provided to the router instance that our Workbench is using. Additionally, the route or the history is being passed to the child components or the micro frontends along with the base name to which the micro frontend is mounted to. So in this case, the prefixes are the app A and app B routes. Now, let's take a look at how our child applications then handle the history. So before the child application passes the history prop to its own router instance, we are actually creating this sort of child history layer based on the shared history. And all our child history does is basically provides this JS proxy layer on top of the history, which provides a couple of replacement methods on top of the native implementations. Namely, the push, replace, and create href methods have been replaced here with our own proxy methods. All these proxy methods really do is append the base name to the provided path parameter and then call the native history method itself with the prefixed paths. So what this enables us to do is to automatically prefix all of the programmatic navigation that's happening within our child application, as well as the DOM href generation. And this makes our micro frontend application sort of agnostic to the base path to which they're being mounted to. And we can even change that base path dynamically without having to worry about that or statically encoding that into our child application. So using this monorepo format and the learner tooling, we can provide isolated front-end development environments with this sort of Workbench setup. In addition, we can provide the seamless navigation as discussed using the React Router and this sort of shared history approach with the proxy layer. As for the third point of app-to-app communication, depending on your project and your needs, there are, of course, multiple ways to achieve that. You could, for example, hook into the normal DOM window dispatch event and event listener methods, or you could pass in custom dispatches or dispatch methods as component props to the child applications. One great thing that has recently come out of React is the context methods, which helps in automatically propagating those kinds of dispatch methods to all of the child components. Also, if you're fine with including additional dependencies to your projects, or you're already using some stream-based libraries like RxJS, then using those for the same sort of event pipeline might make sense. Then as for the final point of visual uniformity, we are using a shared component library. And that shared component library is based on styled components, which is a JS to CSS library. The reason why we chose this sort of JS to CSS approach with our component library is simply the ease of integration with the micro-frontend approach. So all of our components in the component library are sort of their own entities that do not require any specific CSS build pipelines within our micro-frontends. This makes the integration work really easy and makes also the integration of the micro-frontends back into the parent application super easy, as we don't really need to export anything else than the actual JS component. So looking at that tooling and the approaches used here and thinking about what we've achieved with our micro-frontend approach. So first of all, the biggest improvement gained here is the development speed. So going from that 60-second plus initial build time to 10-second initial build time, going from that 15-second incremental build time to almost instantaneous incremental builds, and being able to run the sort of isolated test set within 10 seconds instead of 10 minutes is a huge improvement to the way we work. The second organizational improvement is the team autonomy, as discussed. So letting the teams decide their own tech stack, being able to freely modify that tech stack as needed and as required by their domain. That also usually leads into reduced conflicts in the code base. Also, in generally isolating these sort of functionalities to more strictly contained units leads into better isolated functionality and clearer interfaces between these entities. So if any of these points are stuff that you're sort of struggling with in your front-end projects, then I do recommend trying out some of the tooling presented here and some of the patterns. Also, if you're using some sort of different tools for managing your front-end monorepos as well as your micro-frontends, I would be super interested in hearing about those. Not sure if we have time for questions, but if not, then please feel free to come and grab me by the hand after the presentation. Okay, excellent. Any questions?